question 1, we've got the point with coordinates 3, -4 lying on the curve with equation y is f of x, and we need to state the coordinates of the image of P under each of the following transformations. So we start with y is f of x minus 2. So we are looking at the translation 2 units to the right. Remember that anything that appears within the bracket goes along the direction of x, contrary to what you would expect to do. So we're not deducting 2 from x, we are adding 2 to x, and therefore we take the point 3, -4 to 5, -4. In B, we're looking at y is negative f of x. This is simply a reflection along the x-axis, and we are multiplying y by -1 because anything that was above the x-axis now appears below the x-axis, and therefore we've got this reflection along the horizontal. This means that the point 3, -4 will now be found at 3, 4. In part C, we've got 2y is f of x, so the first thing to do is isolate y, make y the subject. So we've got y is a half f of x, and we are looking at a stretch along the vertical with scale factor a half. We are multiplying all the y's by a half, and therefore 3, -4 will go to 3, -2. And finally, in part D, we've got y is f of x plus 4. The plus 4 is outside the bracket, so it goes along the direction of y. We are translating 4 units upwards, which is equivalent to adding 4 to y, and therefore 3, -4 will go to 3, 0. In question 2, we've got a sketch of the curve y is 2x squared plus 3x and the straight line with equation y is a half x plus 3. As we can see on the diagram, they meet at P and Q, and we need to use algebra, so we need to show all working to determine the coordinates of P and Q. Now, points of intersection can be found by equating the two equations, so 2x squared plus 3x is equal to a half x plus 3. I will get rid of the denominator by multiplying throughout by 2, leading to 4x squared plus 6x is equal to x plus 6. And I will be collecting everything on the left-hand side to give me 4x squared plus 5x minus 6 is equal to 0. Now this factorizes into 4x minus 3x plus 2. All of this is equal to 0. So we've got that 4x minus 3 is 0, or x plus 2 is equal to 0. Now we've got 4x is 3, which means that x is 3 over 4, or x is -2. We found the x coordinates, but we need to proceed in finding the y coordinates. So to find the y coordinates, I can substitute in either the curve or the straight line. I will be substituting the x coordinates into the straight line. So we've got y is a half times 3 over 4 plus 3. This gives y to be 27 over 8. Whereas for x is -2, we've got y is a half times the -2 plus 3, which gives me an answer of 2. Now looking at the diagram given, we see that P has a negative x coordinate, so P has coordinates -2, 2, whereas Q has a positive x coordinate, so the coordinates of Q are 3/4, 27 over 8. In part B, it says, hence write down the range of values of x for which 2x squared plus 3x is greater than or equal to a half x plus 3. Now we have already established the x coordinates of P and Q. They are -2 and 3 over 4, as you can see on the diagram. And we want the curve to be above the straight line, so we want this part and this part here, which I'm highlighting. So I can simply see that we need x to be less than or equal to -2, or x to be greater than or equal to 3 over 4. In question 3, we've got the curve with this equation, and we need to find the y dx, giving our answer in its simplest form. Well, I will start by writing the expression for y in index form. So we've got y is x cubed over 16 minus 4x to the half plus 8x to the -1. Well, we know that when we differentiate, we multiply by the power and we deduct 1 from the power. So this is giving me 3x squared over 16 minus 4 times a half x to the minus a half plus 8 times minus x to the -2. which leads to 3x squared over 16 minus 2x to the minus a half minus 8x to the minus 2. In part B, we are told that the point P with coordinates 4, -2 lies on the curve, and we need to find the equation of the normal, giving our answer in the form ax plus by plus c is 0, with a, b, c being integers. So I will start by evaluating dy dx at x is 4, which simply means I will substitute x is 4 into the expression for dy dx we just obtained, which leads to 3 times 4 squared over 16 minus 2 times 4 to the minus a half minus 8 times 4 to the minus 2, which gives an answer of 3 over 2. Remember, we're looking for the equation of the normal. So what I will do, I will take the dy dx value we just obtained, flip and change the sign. So this gives me minus 2 over 3. Because the normal is perpendicular to the tangent, and 3 over 2 is the gradient of the tangent to the curve at x is 4. And then using y minus y1 is mx minus x1, we will proceed in finding the equation of the normal. So we've got y minus -2, which is the y coordinate of point P, is minus 2 over 3 brackets x minus 4. So this leads to y plus 2 is minus 2 over 3x minus 4. I will cross multiply by 3 to get 3y plus 6 is minus 2 brackets x minus 4. And I will further expand the right hand side to get 3y plus 6 is minus 2x plus 8. Collecting everything on the left hand side gives me 3y plus 2x minus 2 is 0, which is the final answer in the requested form. In question 4i, we are asked to use the laws of indices to write a in terms of b. So we've got 4 to the a over 2 to the 3b is 32 root 2. We do notice that everything is a power of 2. So 4 can be written as 2 squared and all to the power of a over 2 to the power of 3b is 2 to the power of 5 times 2 to the half. Now we know that when we've got a power to a power, we multiply the indices together. So this gives me 2 to the 2a over 2 to the 3b. And on the right hand side, when we've got multiplication with a common base, we add the indices, so we get 2 to the 11 over 2. Now we further proceed by saying that when we've got division, we subtract the indices. So 2 to the 2a minus 3b is 2 to the 11 over 2. And now we've got both sides of the equation being a power of 2, which simply means I can proceed by equating the indices. So we've got 2a minus 3b is equal to 11 over 2. I will multiply throughout by 2 to get 4a minus 6b is 11. And therefore 4a is 11 plus 6b, which means that a is simply 11 plus 6b and all of it over 4. In II, we need to solve the equation 3x is x root 2 plus 14, giving our answer as a simplified third. I will start by collecting the x terms on the left-hand side, so 3x minus x root 2 is 14. I will factor out the x, so x brackets 3 minus root 2 is 14, which means that x is 14 over 3 minus root 2, but we are not done. I will need to rationalize the denominator, so I will multiply by 3 plus root 2 over 3 plus root 2, which means that x is 14 brackets 3 plus root 2, and I will expand the denominators here. So 3 times 3 is 9, 3 times root 2 is 3 root 2, so we've got plus 3 root 2 minus 3 root 2 minus 2, because the root 2 times root 2 gives me 2. We do notice that the 3 root 2 with the minus 3 root 2 will cancel out, and therefore we arrive at x is 14 brackets 3 plus root 2 over 7. The 7 is the 9 minus 2, and I can simplify the 14 with the 7, leaving a 2 in the numerator, which means that x is equal to 6 plus 2 root 2. In question 5, we've got the plan view of a design for a garden pond, and we need to find the perimeter, giving our answer in meters to 2 decimal places. We know that the radius is 3 meters, so this is 3 meters, which also means that this is 3 meters. And to find the perimeter, I'll need to find the AB part here and also the length of the major arc shown here. So to find AB, I will use the cosine rule, which says that A squared is B squared plus C squared minus 2BC cos A. So in my case, the A is the AB. So AB squared is equal to 3 squared plus 3 squared minus 2 times 3 times 3 times cos of 1.25. Remember to set your calculator in radian mode, and therefore AB is simply the square root of this. So 3 squared plus 3 squared minus 2 times 3 times 3 cos of 1.25. This will give me the length of AB. This turns out to be 3.51058 ... And I can also find the length of the major arc here. We know that if this angle is 1.25 radians, then this angle here is simply 2 pi minus 1.25 radians, because 360 degrees is 2 pi radians. So if this is 1.25 radians, this must be 2 pi minus 1.25 radians. Well, we do know that the length of an arc is given by r theta when theta is in radians. So in our case, the length of the arc will be the radius, which is 3, times the angle theta, which is 2 pi minus 1.25. This gives an answer of 6 pi minus 3.75. And therefore, to find the perimeter, I simply need to add the two numbers. So for the perimeter, I'll be doing 3.51058 ... plus 6 pi minus the 3.75, which gives an answer of 18.61 meters. In part B, we are told that there is a uniform depth of water in the pond of 1.5 meters, and we need to find the volume of water in the pond. Well, we need to visualize what's happening. We have already established that the angle here is 2 pi minus 1.25, and we are looking at a 3D shape which looks something like this. We need to determine its volume. Well, we know that we need to do the area of the triangle here and the area of the major sector over here. That would be the cross-sectional area, and if we multiply this by 1.5, which is the length, this will give us the volume. So we can start by reminding ourselves that the area of a sector is given by half r squared theta if theta is in radians, and the volume is given by the cross-sectional area times the length. So in our case, the volume is given by the area of the sector, which is a half, times 3 squared times theta, which is 2 pi minus 1.25. This will give me the area of the sector, which is this part here, and the area of the triangle, I'll find that by doing a half AB sine C. So plus a half times 3 times 3 times sine of 1.25. So this is the area here, and I will multiply this by the length, which is 1.5. Everything is in meters. So if we plug this on the calculator, we get 40.4, and this is cubic meters. In question 6, we've got the 3 points PQR forming a triangle as shown here. Now point M is the midpoint of RQ, and we've got a line L passing through M parallel to PR, so something like this. We need to determine the equation in the form AX plus BY plus C0 for this line. So I will start by finding the coordinates of M, which is the midpoint of QR. We know that for the midpoint, we do x1 plus x2 over 2, so minus 1 plus 7 over 2, comma y1 plus y2 over 2, so 2 plus 8 over 2, which gives us 3, 5, and therefore point M has coordinates 3, 5. Now the gradient of the line PR is given by y2 minus y1 over x2 minus x1. So 8 minus 2 over minus 5 minus negative 1. This gives an answer of minus 3 over 2. And I now have the point through which we pass and the gradient of the line, because we know that parallel lines have the same gradient. And therefore I can proceed with y minus y1 is mx minus x1. This takes me to y minus 5 is equal to minus 3 over 2 brackets x minus 3. I will cross multiply by 2 to get 2y minus 10 is equal to minus 3 brackets x minus 3, which I will further expand to give me 2y minus 10 is minus 3x plus 9. Collecting everything on the left hand side leads to 2y plus 3x minus 19 is equal to 0. In part B, we are told that the line L cuts PQ at the point N, and we need to find the coordinates of N and the area of the triangle MNQ. Well, let's start by reminding ourselves that we have found the coordinates of M to be 3, 5, and we've got the straight line L with equation 2y plus 3x minus 19 being parallel to PR passing through M, and the point of intersection of this line with PQ is the point N. So since N lies on PQ, it must be the case that its y coordinate is 8. So this will help me determine the exact coordinates of point N. So let's start by stating that at N, y is 8. So I will substitute 8 into the equation of the straight line here, which means that 2 times 8 plus 3x minus 19 is equal to 0. Which takes me to 3x minus 3 is 0, 3x is 3, and therefore x is 1. This means that point N has coordinates 1, 8, which means I can go back to my diagram here. So this is N, 1, 8. Now to find the area of the triangle NMQ, let me start by highlighting the triangle and observing that the base is simply the distance NQ, which is the difference between the x coordinates of N and Q, which is simply 6. Now the height is this distance here, which is the difference between the y coordinate of 8 and the y coordinate of 5. So this is simply 3. And therefore we can simply say that the area of the triangle NMQ is simply base times height over 2, which is 6 times 3 over 2, which works out to be 9 squared units. In question 7a, we need to sketch y is 2 cos x and y is tan x on the given diagram. So for 2 cos x, we're looking at a stretch along the y direction by a scale factor of 2. So the graph should look something like this. The maximum is at 2, the minimum is at negative 2, whereas for tan x, we know we've got asymptotes at 90 and every 180 degrees, so at 90, 270, at minus 90, so the graph looks something like this. Now to deduce in terms of N, the number of real solutions of the equation 2 cos x is tan x. Obviously, since we've got the two graphs, we are looking at the points of intersection between the two graphs. We can see that between 0 and 360, we've got 2 points of intersection. The two graphs do not meet between 0 and minus 90, so we don't really care about this part. So since we have two solutions in 360 degrees, if we've got 360 n such regions, then obviously the number of solutions will be multiplied by n, and therefore for BI we've got 2n solutions. Now for tan x being minus 3 over 2 over the same interval, I will start by drawing the horizontal line y is minus 3 over 2. We see we've got 3 points of intersection, so 1 in the negatives and then another 2 in the positives. So again, we can see that within the span of 360 degrees, we've got 2 solutions, which means that every 360 degrees will contribute 2 solutions. So between 0 and 360, we will be having 2n solutions, plus that extra 1 solution between minus 90 and 0, so 2n plus 1 for BII. In question 8, we've got a sketch of the curve with the equation given here. It's x plus 2, x minus 10 to x minus 3. It's a cubic curve. We need to deduce the values of x for which f of x is greater than 0. Now the prompt to deduce means there is no extensive work needed here. Well, we've been given f of x in a factorized form, which means I can easily extract the roots, the cuts on the x-axis. So when x plus 2 is 0, when x minus 10 is 0, and when 2x minus 3 is 0, I get the 3 cuts to be minus 2, 3 over 2, and 10 as shown. and we want f of x to be greater than 0, so we want this hump here and this part of the curve, which I'm highlighting in red. So my answer to part A will simply be minus 2 less than x less than 3 over 2, or x being greater than 10. It's a strict inequality because I'm solving a strict inequality. In part B, we are asked to expand f of x to the given form. A and b are integers to be found. So starting with f of x given in the factorized form, I will keep the x plus 2 and I will expand the last two brackets. So I get 2x squared minus 3x minus 20x plus 30. I will collect the like terms within the second bracket. It's 2x squared minus 23x plus 30. And I will further expand to get 2x cubed minus 23x squared plus 30x plus 4x squared minus 46x plus 60, which leads to 2x cubed minus 19x squared minus 16x plus 60. We see that the leading term of 2x cubed has been recovered, as well as the constant term of 60. In CI, we need to sketch the curve with equation y is k over x plus 60, with k being a positive constant, showing clearly the position and equation of the horizontal asymptote to the curve. Now we know that this is a reciprocal curve. When x is 0, we've got division by 0, which is not allowed, it's not valid, and therefore x is 0, is a vertical asymptote. Now for the horizontal asymptote, we can see this term vanishing, and we see that y is 60 is the equation of the horizontal asymptote. Notice that the expression we obtained in part B gave a constant term of 60. This is the y-intercept of f of x, which means that the equation of the asymptote y60 should pass through the cut on the y-axis for f of x, and the graph should look something like this. Remember to state the equation of the horizontal asymptote to claim all marks for this part. In II, it says, hence deduce the number of real roots to the equation f of x is k over x plus 60. Obviously, we are looking at the points of intersection, and we've got two such points as shown here. So it's easy to conclude that we've got 2 points of intersection and therefore 2 real roots. Question 9, we've got a sketch of the curve C with a given equation. We are told that the curve crosses the negative y-axis at point P as shown. The line L1 has a gradient of 2, so let me note this down. The gradient is 2, passing through P, and we need to find the equation of the line L1 in the form y cos mx plus c. So I will start from the fact that at P we've got a cut on the y-axis, which means that x is 0. I will be substituting, so 4 times 0 squared plus 9y squared plus 4 times 0 times y is 64, leading to 9y squared is 64, and therefore y squared is 64 over 9. Now to find y, I will simply take the plus minus square root of 64 over 9. So this is giving me plus minus 8 over 3. Now we know we are cutting the negative y-axis, and therefore we conclude that point P has coordinates 0, minus 8 over 3. Now this happens to be the y-intercept of the line L1, for which the gradient has been given to be 2, and therefore we conclude that the line L1 has equation y is 2x minus 8 over 3. We then have that the line L2 has equation y is 2x plus k, k being a constant, and we need to show that the y-coordinate of any points where L2 meets C are solutions to this equation here. So we start with y is 2x plus k. We are trying to combine the original equation of the curve with the line y is 2x plus k to arrive at something that involves y and k only. So we need to substitute for x. So we can see that y minus k is equal to 2x, and we've got the 4x squared plus 9y squared plus 4xy is equal to 64. This is the equation of the curve C. I will write 4x squared as 2x and all squared plus 9y squared plus 2x times 2y is equal to 64. This will help me when I substitute for 2x, so that whenever I see 2x, I will be writing y minus k, and this leads to y minus k all squared plus 9y squared plus brackets y minus k times 2y is 64. I will proceed by expanding, so y squared minus 2ky plus k squared plus 9y squared plus 2y squared minus 2ky is equal to 64. I will be collecting everything on the left-hand side, collecting like terms together, leading to 12y squared minus 4ky plus k squared minus 64 is equal to 0 as required. We are then told that the line L2 meets C at two distinct points, and we need to determine the range of possible values for k. Well, we know that if we are meeting at two distinct points, this means that the discriminant of this quadratic should be greater than 0. So looking at the quadratic, this is the coefficient of y squared, so this is the a. The b is the minus 4k, the coefficient of y, and the c is the k squared minus 64. So the discriminant, we know that this is b squared minus 4ac. So in our case, it's minus 4k squared minus 4 times 12 times k squared minus 64. So this is leading to 16k squared minus 48 times k squared minus 64. I will further expand this to get 16k squared minus 48k squared plus 3072, which is equal to minus 32k squared plus 3072, and we need this to be greater than 0, leading to 3072 greater than 32k squared. If I divide both sides by 32, I get 96 to be greater than k squared, so that I can proceed in finding the critical values. So for the critical values, I treat my inequality as being an equation. So we've got 96 is k squared. So plus minus the root of 96 is the value for k, the critical values. This simplifies to plus minus 4 root 6 for k. And I can now draw my parabola. It's a smiley shaped parabola with the cuts being at the critical values of minus 4 root 6 and 4 root 6. We can see that we go plus, minus, plus, and we wanted k squared to be less than 96, so we go for the less than, the negative region, which is the region in between, and therefore we conclude that the range of values for k is between minus 4 root 6 and 4 root 6. In 10i, I need to find the integral of 2x minus 1 over 4 root x dx, giving my answer in its simplest form. So starting with the given integral, I will split it as the integral of 2x over 4x to the half. Remember, the root of x is x to the power of a half, minus 1 over 4x to the half dx. This is the integral of a half x to the half, because when I have x divided by x to the half, it's x to the 1 over x to the half, and I deduct the powers, minus a quarter x to the minus a half dx. Now remember that when we integrate, we increase the power by 1 and divide by the new power. So this will give me a half x to the 3 over 2 over 3 over 2 minus a quarter x to the half over a half, and plus a constant of integration. Now the 2 with the 2 will cancel out, and the 4 with the 2 leaves me a 2 in the denominator. So this simplifies to a third x to the 3 over 2 minus a half x to the half plus c. In II, we've got a curve C with equation y is f of x. We are told that the derivative is ax squared plus b. The gradient of c at the point 35 is 4, and the y-intercept of the curve is negative 5, and we're being asked to find f of x. So I will start with f dash of x is ax squared plus b, knowing that the derivative, the gradient at 3 is 4, simply means that f dash of 3 is equal to 4. So this is giving me 4 is a times 3 squared plus b. So 4 is 9a plus b. I will now proceed in finding an expression for f of x by integrating f dash of x. So f of x is the integral of ax squared plus b dx. So this is giving me ax cubed over 3 plus bx plus c, the constant of integration. Now, we have been told that the y-intercept of c is -5, which simply means that f of 0 is -5. So this gives me that -5 is equal to c. And I can also use the fact that the point 35 is a point on the f of x. So we have that f of 3 is equal to 5. And therefore 5 is equal to a times 3 cubed over 3 plus 3b, and the c, which was -5, leading to 10, is 9a plus 3b. So we now have two equations that involve a and b. I will label them as 1 here and 2, the equation we just arrived at, and I can see that I can subtract one from the other. So if I do 2 minus 1, we have that 10 minus 4 is 6, and the 9a with the 9a will cancel out, and the 3b minus b will give me 2b. So 6 is 2b, which means that 3 is equal to b, and I can go back maybe to the first one to substitute b is 3 and find the value of a. So we get that 4 is equal to 9a plus 3, leading to 1 is 9a, and therefore a is a 9th. So the only thing missing is for me to write the full expression for f of x. So we have that f of x is 1 over 9 times x cubed over 3 plus 3x minus 5, which of course simplifies to x cubed over 27 plus 3x minus 5.